Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the concept of digital comparators. The digital comparator is another very useful combinational logical circuit which is used to compare the value of two binary digits. The digital or binary comparators are made up from standard and, NOR, and NOT gates that compare the digital signals present at their input terminal and produces an output depending upon the condition of those inputs. For example, along with being able to add and subtract binary numbers, we need to be able to compare them and determine whether the value of input A is greater than, smaller than, or equal to the value of input B. The digital comparator accomplishes this using several logical gates that operates on the principles of Boolean algebra. There are two types of digital comparator available. They are identity comparator and magnitude comparator. In the case of an identity comparator, it is a digital comparator with only one output terminal for when A is equal to B, either A is equal to B is equal to high or 1, or A is equal to B is equal to 0 or low. When it comes to a magnitude comparator, it is a digital comparator which has three output terminals, one each for equality, that is A is equal to B, greater than, that is A greater than B, and lesser than, that is A less than B. The purpose of digital comparator is to compare a set of variables or unknown numbers, for example A, against a constant or a unknown value such as B, and produce an output condition or flag depending upon the result of the comparison. For example, a magnitude comparator of two 1-bit input would produce the following three output condition when compared to each other, that is A greater than B, A is equal to B, and A less than B, which means A is greater than B, and this is useful if we want to compare two variables and want to produce an output when any of the above three conditions are achieved. For example, produce an output value from a counter when a certain count number is reached. Now we are considering a 1-bit digital comparator circuit. Firstly, the circuit does not distinguish between either 2-0 or 2-1 as an output A is equal to B is produced when they are both equal, either A is equal to B is equal to 0 or A is equal to B is equal to 1. Secondly, the output condition for A is equal to B resembles that of a commonly available logic gate, the exclusive NOR or XOR function on each of the n bit given. The digital comparator actually uses exclusive NOR gate within their design for comparing their respective pair of bit. When we are comparing two binary or BCD value or variable against each other, we are comparing the magnitude of these values. A logic 0 against a logic 1, which is where the term magnitude comparator comes from. So when it comes to a 2-bit comparator, a 2-bit comparator compares two binary numbers, each of 2-bit, and produces their relation such as one number is equal or greater than or less than the other. The figure shows the block diagram of a 2-bit comparator which has 4 input and 3 outputs. The first number A is designated as A0 and A1, and the second number is designated as B0 and B1. This comparator produces three outputs, that is A greater than B, A is equal to B, and A less than B. The truth table of this comparator is shown here, and it depicts the various input and output status. So dear students, this is just introduction to the term or the concept known as a digital comparator, and the digital comparator is a very useful logical combinational circuit which is used to compare the value of two binary digits. So my dear students, in the upcoming lecture we will discuss the concept relating counters. So dear students, see you soon. Until then, goodbye, thank you, and all the best.